Take a look at section 6.3, which is more trinomials. The trinomials in this lesson do not start with their leading coefficient as a 1. What that does is it puts combinations that we have to decide which ones do we pick, okay? But the method I call this is trial and error. We didn't make a single error in section 6.2. I said, is it this? You'd say yes or no. Then when it came time we found it, we put them in the right spots. We were perfect. We were flawless. We're going to make some mistakes. I'm going to erase when I make a mistake. So if you're taking your notes in ink, that could be a problem. Okay, I'm just telling you, I'm going to write down things that get changed. At the end, and you just look at my document, you won't know what happened. But if you want to see the process, you can look at the video, and you'll see it as it developed. All right, each of these is going to tell me to factor completely. Factor completely. So these are going to be like your math lab questions. Number 1, I would like to factor completely 77x squared plus 134x plus 45. We start out with a bunch of big numbers. Okay. The questions do not change at all. The first question is there a common factor? Now we can ponder this because they're bigger numbers. 77 has only as factors 7 and 11. And 7 and 11, neither one go into 45, so no, there's no common factor. Okay. The next thing I notice is it is a trinomial, so I'm going to try trial and error. The sign patterns are the same. The last one is positive, which means what? Take the sign of the middle term, they are both pluses. Now here's where it begins to be different. I do know that I'm going to need an x and an x to get an x squared for the first one. But I'm not just getting x squared anymore. I have to get 77. So, off to the side, I'm going to write down the different ways I could multiply two numbers together and get 77. It could be 1 times 77. It could be 7 times 11. And at this instant, I have no idea which one is right. Okay? That's all my choices. Now I have to go to the other side and say, all right, now the last times the last has to give me 45. How many different ways can I get 45? Well, it could be 1 times 45. It could be, let's see, 2 doesn't go into it, but 3 does. 3 goes in there 15 times. 4 doesn't go into 45, but 5 does. 5 times 9, and I believe those are all my choices. So I'm going to try to kind of color code this a little bit. My first, I'm going to do blue, and my last, I'm going to do green. Now here's the deal. The outer product plus, and how do I know it's a sum? Signs are the same. The outer product plus the inner product has to add up to be 134. Okay? But it is no longer just look at the numbers over here, because different numbers are getting multiplied by numbers, and then we're getting to add them. And that's why it's sometimes called trial and error. Now, most of us have this initial instinct of, I'm not going to write it down till I know what's right. Do not feel that way. Jump in there and start doing something and have a good eraser ready, because you most likely will make some errors. Now, even though I have the answers sitting right here in front of me, and I've been doing it for, oh my gosh, decades and decades, so I have some decent instincts developed. I'm not going with my instincts. I'm just going to randomly pick things, and I want us to experience trial and error and trial and success, because that's what's going to happen to you. All right, would you like me to try 1 and 77 or 7 and 11? Just pick one. 7 and 11. Okay, I have a brave soul who just says pick that. So keep in mind that I'm going to erase them if they're not right. Now here's my process. When I put 7 and 11 in there, I'm going to anchor those and not touch them till I have exhausted everything over here, which means 1 and 45, 45 and 1, 3 and 15, 15 and 3, 5 and 9, 9 and 5. I have a lot of things to try. All right, I'm going to start at the bottom. I do usually pick factors to start with that are closer to being the same size rather than picking the extremes. Okay, that's just me, and it's not necessarily going to be right every time. All right, so I pick 5 and 9. Okay, let's see where we are. The outer product is 63x. The inner product is 55x. Do those add up to be 134? No. Okay, now that only tells me one thing. This combination in this order is not right. So erase, 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 erase. The next thing I do is take the 9 and the 5 and switch them. Put the 9 here and the 5 here. See, I anchor the first choices, and then I put in a pair and swap them when they don't work. The outer product is 35x. The inner product is 99x. And what is their sum? 134x. Now, believe it or not, there is cause for a little celebration because we only made one error. I had them in the wrong spots the first time. It could, yes. The comment, yes, that could take a long time because there are, if you just consider that you're going to keep these stationary, so this is 2 choices, but you're going to move these, so that's 6 choices, so that's 12 possibilities. We got it on the second try. You will very rarely go through all 12 possibilities before it happens. And that's why when you start seeing a first number or a last number that's a prime number, you're going to say, thank you so much, because prime numbers only have one set of factors. And when you see numbers like 144, you're going to say bad words about me, because 144 has a lot of choices. Okay, I wouldn't do that to you on a test. I'm careful about the problems on a test. Let's look at number 2. I have 27y squared minus 35y plus 8. And let me make this so it's the only thing showing. There it is. Okay, step 1. Is there a common factor? 27, 35, no. It's a trinomial. I'll go with trial and error. Tell me about the signs. Both will be negative. When the last sign is positive, they both match the middle term. They are both negative. All right. I know that I will need y's in here, but I've got to work with the factors of 27. Factors of 27. 1 times 27 gives me 27. 2 doesn't go into it, but 3 does. 3 times 9. I don't think there's anything else. I think that's it. So now let's look down here at 8. Factors of 8. 1 times 8. 2 times 4. Not quite as many choices this time. Because they have the same sign, I'm going to be looking for a sum of 35. What would you like me to start with? 3 and 9. Okay, 3 and 9. I've anchored those, and I will try everything else and leave those. So you want to go to 2 and 4? Okay, 2 and 4. The outer product is negative 12y. The inner product is negative 18y, which add up to be negative 30y, and that's not right. Okay. So the next thing I do is stick with the 4 and the 2 and change them, because now they're paired up with different numbers. The outer product is negative 6y. The inner product is negative 36y. And do those add up to be 35? No. All right. Here's what I know so far. That I have a good eraser, and that 3 and 9 don't work with those. Okay? So now, I'll see if they work with 1 and 8. The outer product is negative 24. The inner product is negative 9. They had y's on them. And that's negative 33. No, that didn't work. Go away. All right, so I'll move the 8 here and the 1 here, and it just got worse. Because now my outer product is negative 3y, my inner product is negative 72y. Ooh, okay. So what I know now is that nothing works with 3 and 9. Okay. Remember the name of the technique, trial and error. I'm so sorry, but we just made a bunch of errors. I know 3 and 9's not right. Nothing worked with it. So I'll go with 1 and 27, which would not have been my first choice either. And I have to start over with my 1 and 8 and my 2 and 4. So I'll try 1 and 8. Okay, the outer product is negative 8y. The inner product is negative 27y. And what's the sum of those two? Negative 35. Yay. You're not admitting it, I know, but there is a little tiny celebration that goes on inside your head when you get it right. So that time, my normal mode of picking the more moderate factors didn't lead us to the right answer. It was the extreme factors that did. Okay, let's look at 3. I have 2x squared minus 9x minus 5. Bless you. Is there a common factor? No. It's a trinomial, so I'm going to try trial and error. Tell me about the signs. It's going to be one of each. And I know that I'm going to have x's. Now, can we say a big thank you for prime numbers? Look at the 2 that's in the front. There's only one way to get 2, and that's 1 times 2. Thank you so much. The last number is a prime, 5. There's only one way to get 5, 1 times 5. Now, certainly, I can put them in the wrong spots, but I've only got 2 ways to do this. I'm going to put 1x and 2x. Now tell me, am I going to be looking for a sum to get 9 or a difference to get 9? They're different. When they're different, difference. Okay, different signs means you're going to use a difference, which means you're going to subtract. Okay, it does matter where you put them. I might happen onto it, and then again I might not. What's the outer product? Minus 1x. What's the inner product? Positive 10x. What's their difference? 9x. Okay. Am I finished? Am I correct? No. I got a 9x. And I feel pretty good because this is a 9. But I got positive 9. And this is negative 9. I only have to do one little thing. If I get the right number with the wrong sign, then all I have to do is change the signs. And now the outer product is positive 1x and the inner product is negative 10x, and so now the sign is right. So when I have one of each, and I'm going to do a difference, I don't worry up front about, ooh, should I put the plus here? Should I put the minus here? I don't care. If I can just get a 9, if the sign's right, I'm done. If the sign's opposite, I move the signs. So the signs are the easiest thing to fix at the end. Let's look at number 4. By the way, this lesson can be challenging when you're doing my math lab, but I will promise you that the test questions that I pick to go on a test will not be killer questions. Math lab, you've got time. You might get a little frustrated, but you've got time. Testing, I'll make them friendly. All right, number 4. How about 35r squared plus 48r minus 27? Okay, is there a common factor? No. Okay, before it's over, the answer will be yes to something, but not yet. Tell me about the signs. One positive and one negative. How do you know? Because the last sign was negative. When the last sign's negative, it's always one of each. All righty. So I'm going to be looking for a sum or a difference? Difference, because they're different. All right, let me sneak in my R. All right, factors of 35. 1 times 35 and 5 times 7. I think that's it. Factors of 27. 1 times 27. 3 times 9. Okay. Don't be scared that you're going to write something wrong. Be ready to erase and try to kind of keep up with what you're doing. It didn't work for me last time, but I'm going to try it again anyway. I'd like to start with 5 and 7. Those are anchored. I'm going to try every combination over here. So let's start with 3 and 9. The outer product is negative 45r. The inner product is positive 21r. Is that a difference of 48? No? Okay, so that didn't work. Remember, anchor those first ones. Don't change those. Now, what do I need to change? I need to put the 9 there and the 3 there. Is that right? Okay. Now my outer product is negative 15r. My inner product is positive 63r. What's their difference? 48. All right, cause for a little minor celebration. Yippee. Okay. We partied. All right, number 5. Let's take 2m squared plus 17m plus 22. Whoop. Is there a common factor? No, not yet. Tell me about the signs. Both positive. I know I need an M and an M. Okay. At least the leading number is a prime, so it has to be 1 times 2. The back number, 22, it's either 1 times 22 or 2 times 11. So I don't have too many choices here. I will start with the 1 and the 2 as the coefficients of M. Now will you tell me whether I'm going to be looking for a sum or a difference to add up to 17? A sum. Okay, so what do you want me to try? 2 and 11? 2 and 11. The outer product is 11m. The inner product is 4m. And that's not right. So I'll try 11 there and 2 there. The inner product is 22m, and the outer product is 2m. That didn't work, did it? Okay. With the 1 and the 2, I tried both ways of 2 and 11, and it didn't work. Don't move the 1 and the 2. Now 1 and 22. Well, is there any way that I can use a 1 and a 22 and I'm going to end up getting only 17? I mean, you can certainly try them any way you want, but it's going to be too big. Switch it and it's worse. Okay, 2 and 11 does not work. 1 and 22 does not work. What's our conclusion? Nothing works. Nothing works. When nothing works, the mathematical name for that is this has no factors other than itself and 1, which means it's prime. It is a prime polynomial. When you can't factor, it's called prime. My math lab will tell you to type a capital P for prime. Getting prime is irritating because you feel like, well, at least I feel like sometimes, did I check everything that was possible? Have I exhausted all the possibilities? When you take a test, I at least will tell you how many primes are on the test. You know, if there are 4 primes, I'll say 4 of them are prime, so that you'll know. Well, it was in summer 1 when I had a story. We'll resume. I will tell you how many primes are on the test, and I won't lie to you about it. All right, let's look at number 6. Oops. All right. I would like you to factor 28b squared minus 212b minus 96. Almost all of us go, ugh, look at those big numbers. What are you supposed to ask yourself first? Is there a common factor, and what is the greatest common factor? All right, now they're all even, so you might factor out 2. But you know what? When you factor out 2, they're still all even. 4. Okay, so we're going to go ahead and recognize that 4 is the greatest common factor, and you might have had to try 2 and then try 2 again. So if I divide each of these by 4, I will get 7b squared minus 53b, is that right? Plus 24. I'm trying to divide in my head, so I hope somebody's checking me. It is minus. Thank you. That sign had no reason to change other than my carelessness. All right. I was able to factor out a common factor, and it's the greatest one because these no longer share a common factor. Does this look like something that maybe we can do by trial and error? Yeah. So I'm going to keep the 4 and put my parentheses. I'm going to underline it with a highlight so I won't mess up and go looking in the wrong spot. All right, factors of 7. 7's a prime, isn't it? Yeah. Yeah, so it's 1 times 7. So I know I'm going to get, oh, I think I neglected to talk about signs. Okay, could you tell me what the signs will be? 1 of each. It's not like the earth will quit spinning if you don't fill those in real quickly, but I try to do that as my first step. All right, 24. Ooh, 24 has a lot of choices. It's 1 times 24, or 2 times 12, 3 times 8, and 4 times 6. Thank goodness 7 was a prime, because I have 1 and 7 with each of these forward and backward. Okay, so I have my eraser ready. I know I'm going to have a 1b and a 7b. And those are anchored. Those are not going to move. All right. Am I going to look for a sum or a difference to add up to be 53? A difference. That's a pretty big difference. So I'll just say it's a pretty big difference. All right. Somebody here, just tell me some numbers to start with. 12 and 2. Okay, I heard somebody say to start with 12 and 2. So I'm going to put 12 and I'm going to put 2. 12 times, for the inner product, that's 84b, and the outer product is minus 2b, and that way doesn't work. So I'll try 2 up here and 12 down here. That's going to give me 14b. That looks like a 7. And the outer product is minus 12b, which is only 2b, and that's not right. All right, what we've discovered, we tried them both ways. 2 and 12 don't work. 1 and 24? Somebody's shaking their head no, because it sounds like maybe you've already tried it. 4 and 6. Now, sometimes this is what it takes. Just keep working with it. The outer product is negative 6b, the inner product is 28b, and that's not right. So I switch them, to 6 and 4. Well, that gives me 42b, and this gives me negative 4b. No. Trying to get 53. Thank you. We're going to 8 and 3. The inner product is 56b, and the outer product is minus 3b. A small hallelujah, because I got 53b, but not a big hallelujah because the signs are wrong. But is that a big deal? Okay, it's a big deal as far as leaving it, but it's not a big deal to change. We just grab our eraser, and now, one last time, I'm going to check it. The outer product is 3b. The inner product is negative 56b, and that's correct. Okay? Now, I think it's important for us to experience not knowing what we should pick and just going through the choices. Okay, we ended up with 3 and 8 working when we finally got them in the right spots. Okay, we did have a GCF first. Let's do one more of these, and then I have one other little topic to talk about. Let's jump to number 8, which is negative x squared plus 9x plus 70. The reason I picked this one to do as an example is because there's not a common factor. But do you notice that the leading term is negative? Do you vaguely remember yesterday that I talked about we don't want to leave a leading term negative? I don't have a number to factor out of these unless I factor out negative 1. So my common factor is negative 1. Why am I doing it? I'm doing it solely because the leading term was negative. When I divide each of these by negative 1, what does that do to their signs? It changes the negatives to positive and the positives to negative. So I end up with x squared minus 9x minus 70. That's a very important step because the sign patterns that I've been trying to drill into you depend on the first term being positive. They're not valid if the first term is negative. Okay, so keep the negative 1 or just a negative sign. And let's see if we can factor this the rest of the way. If the last number is a negative, what does that tell you about the signs? one of each, one plus and one minus. Are you feeling somewhat happy seeing just an x squared here? You should, because there's just one way to get x squared, and that's x times x. So now I do have to work with the factors of 70. Am I looking for factors that add up to be 9 or have a difference of 9? Difference. So 1 times 70 won't work. 2 times 35 won't work. How about 5 and 14? Do those have a difference? I'm sorry, I don't even know if I said. Do those have a difference of 9? Yes. Now, there's also 7 times 10. I didn't ever need to get to that because I found my choice. See how nice it is when the leading term is a 1? Because I don't have to worry about combinations of things, just worrying with these numbers. And so, now, can you even tell me the right place to put them? The big number needs to go with the negative. That gives me an outer product of negative 14x and an inner product of 5x, and yes, that turns out to be that negative 9x. I heard the celebration, yeah. Okay, so we skipped 1 or maybe 2 in that group, but I hope we did enough to practice. There is one more little thing that is discussed in this section 6.3, and I need to review something first. I want to review squaring a binomial. If you actually did not discuss the technique that we're about to do, you could still factor all of our trinomials and make 100 on the test. This will still help you, though. It'll help you be a little faster under certain circumstances. So I want you to review, how do you square a binomial? What if I have x plus 3 quantities squared? Well, the long way that I don't want you to have to rely on is to take x plus 3 times x plus 3. And that would give you, product of the first is x squared. What's the outer product? 3x. What's the inner product? 3x, which add together to be, I heard a 9 and wanted to use it, 6x. And what's the product of the last? That's the 9. I don't want you to have to do all that when you're squaring a binomial, because there is a shortcut. The shortcut is, take the first one and square it. X times x is x squared. To get the middle term, what you do is multiply these two for 3x. That number expression represents the inner and the outer, so what you have to do is double it. 3x plus 3x is 6x, and then square the last for 9. So this one is 3x plus 3x for the middle term. Let's do one more of those. Let's suppose I have 4x minus 7 quantities squared. We're just going to do it the shortcut way. Square the first. 4x times 4x is 16x squared. And I see a lot of people leave off exponents sometimes. Don't leave those off. Now, to get the middle term, what you do is multiply. 4x times negative 7 is negative 28x. Do I write down negative 28x? No, I need to double it, because that's both the inner and the outer. So I write down negative 56x, because it's 28 and 28. Then I square the last one for 49. 7 times 7. A positive? Because this number, when you multiply it times itself, negative times negative is a positive. This number will always be a positive. The 56, I multiplied these two, is 28. But that represents both the inner and the outer. So I have to literally add another negative 28x to it. So I have to double it. Okay? Now, here's going to be your job. Can you recognize when a trinomial has been created as the result of squaring? Okay? A trinomial that is the result of squaring is called a perfect square trinomial. The number 49 is called a perfect square because it is 7 squared. The trinomial 16x squared minus 56x plus 49 is called a perfect square because it's the result of squaring something. Your job, should you decide to accept it, is to recognize that it's a perfect square trinomial. I'm going to try to give you the tools to do that. But you know what? If you don't recognize it, you just put your 2 sets of parentheses and go on your business with trial and error, and you'll get the right answer. So let's look at a few. Now, I think that my math lab, it's just continuing in 6.3, I think it gives you this nice little hint and says, factor the following perfect square trinomial. Well, that takes all the fun out of it. They tell you it's a perfect square. I'm not going to tell you it's a perfect square on the test. All right, so let's see if we can recognize it. I'm going to ask you to factor x squared plus 4x plus 4. Here's how you test it. You look at it and you say, first, is there a common factor? No. Secondly, you might almost jump in there with your 2 sets of parentheses, but instead you say, wait a minute. Is this a perfect square? Yes, it's x times x. Is this a perfect square? Yes, it's 2 times 2. Then there's a really strong likelihood that this is a perfect square trinomial. And by the way, this will always be positive if it's a perfect square. Okay, now I'm going to take a chance and hope that it is. I'm going to take that chance, and I've always got my eraser in case I'm wrong, and I'm going to write down that it is something squared. All right. In the first spot goes the square root of that. What times itself gives you x squared? X times x. Always, always, the sign comes from the middle. What's the square root of 4? 2. Now, I haven't checked it yet. I know that x squared is x squared. I know that 2 squared is 4. What I have to check is multiply them for 2x, double it, and do you get 4x? Then I've got the factors. I'm done. If you didn't like doing that, then you could have done double parentheses and said, oh, let me think through all this stuff. The last sign is positive. That means they're both pluses. I know I need an x and an x. I need factors of 4 that add up to be 4. It has to be 2 and 2. Okay, now in this one, it was just as fast to do it this way, but not always. I do not know whether MathLab would give you credit for this version of the answer or not. Because MathLab is saying this is a perfect square trinomial, it probably wants this version, where you're going to have to type it in, hit your exponent key, and then hit that. And, okay, my remote's dead. Life goes on. Let's see, right there. Number 10. I would like you to factor x squared minus 16x plus 64. Is there a possibility that this is a perfect square trinomial?
Yes.
Is that a perfect square?
Yes.
Is that a perfect square?
Yes.
Then there's a possibility. And in my mind, it's worth trying. So I will start by writing that down. What's the square root of x squared? What sign do I use? Negative, because it always comes from the middle term. What's the square root of 64? 8. I'm not convinced yet that I'm right until multiply them for negative 8x, double it, meaning that you think of another one, and is that negative 16x? Now, maybe you can do this checking in your head. I don't know. The middle term is twice the product of the square roots. Square root of this is x, square root of this is 8, twice that is 16x.
Then when you get to the bottom, you add those two.
Yes, ma'am. Uh-huh.
But I thought you said negative and negative giving positive.
Only under addition. If you lost 5 pounds and then you lost 5 more pounds, you better hope that you're at loss of 10. Either that or I'm finding a different diet. Keep back. Number 11. 36x squared plus 60x plus 25. If you're asked to factor that, there's no common factor. Is it potentially a perfect square trinomial? Perfect square, perfect square. So I think it's worth trying. What's the square root of 36x squared? 6x. What sign do I write down? And what's the square root of 25? Now, I need to check the middle term. Multiply those for 30x, double it for 60x. So is it right? There is a possibility that the first term can be a perfect square and the last term can be a perfect square and the middle term won't work out as a perfect square trinomial. And in that case, you have to go back and do it by trial and error. I wouldn't do something mean like that to you. Let's do our last problem, number 12. Let's factor 2n squared minus 4n plus 2. What are you supposed to look for first? Common factor. Do you see one? 2. So I'm going to factor out the 2. When I divide out the 2, I get n squared minus 2n plus 1. Well, looking at the first and the last, does this look like it might be a perfect square trinomial? 1 is a perfect square. So, yes. Now, don't neglect your poor little old 2 over there. I think it might be a perfect square trinomial. What's the square root of n squared? N. What sign do I use? And what's the square root of 1? 1. Let's check the middle term. If I multiply these, I get negative 1n. And if I double it, I get negative 2n. And it does check. So perfect square trinomials, if they are indeed perfect squares, you don't have to worry about lots of combinations to come up with the right one. Okay, so that concludes 6.3. We're going to continue with factoring, and today we're going to look at a method that's sometimes called trial and error. It is sometimes called guess and check. Some teachers teach it, and they call it the box method. Have any of y'all learned it as the box method? Okay, good, because I don't use the box method. So I'm not going to be confusing you, I hope. All right, in order to be really good at trial and error, we need to review FOIL, which is the acronym first, outer, inner, last, which is a way to multiply two binomials. So let's take a look at about 4 examples. Let's look at x plus 3 times x plus 5. What's the product of the first terms? X times x. It will give you x squared because you'll add the exponents. Now, the outer product is 5x. The inner product is 3x. And if you add those two together, you get 8x. And then the product of the last, and I'm moving kind of slowly with this. I know most of you are better at FOIL than I'm leading you to believe, is 15. So is everybody okay with that? Okay, first, outers plus inners, and last. Let's take a look at another example. And the only thing I'm going to change up in this is I'm going to make it x minus 3 times x minus 5. Once again, the product of the first is x squared, x times x. The outer product this time is negative 5x, and the inner product is negative 3x. They're both negatives, so what do? Add them up, keep it negative, negative 8x. What's the product of the last? It's still positive 15. So if you take a look at those two, you notice that both of them got as their last terms positive 15. But the first example got a positive 8, and sure enough, both of the signs here were positive. The second one got as its middle term negative 8, and both of the signs were negative. Okay, so I'm just asking you to make some observations. Yes, question?
Yeah, I'm lost. How did you get the 8x?
I got the 8x, this 8x, by adding the outer product, which was negative 5x. Negative 5 times x is negative 5x. The inner product is negative 3 times x, which is negative 3x. A negative 3x and a negative 5x add together to be negative 8x.
I'm sorry, I don't know. Maybe the way I study is different, but I just want to be clear. I thought x and x is x. Where?
Okay, in multiplication, x times x is x squared. But in addition, where you have a negative 3x and you're adding it to a negative 5x, when you add them, you simply add their coefficients. So if I had written down all the terms, I would have had x squared minus 5x minus 3x plus 15. And to add these two, they are like terms. All I do is add their coefficients and keep the variable. Okay? And I hope that you notice the sign patterns. And I'm asking you to look at it now, and then we'll summarize together in a minute. All right, let's look at another one. Number 3, what if I have x plus 3 times x minus 5? Let me scoot this up. The product of the first, x times x, is x squared. The outer product is negative 5x. The inner product is positive 3x. Now this time they have different signs. So if I have one positive and one negative, I subtract, keeping the sign of the greater one, for minus 2x. Product of the last is minus 15. So this time I got a last term which was negative, and that makes sense because I multiplied one positive times one negative to get that minus 15.
Can you do that one more time? Please?
Sure. The product of the first, x times x.
Yeah, I got that.
Okay. Okay, x squared. So the outer product, because the 5 is negative, gives me negative 5x.
Oh, okay.
Okay, and the inner, because it was positive, gave me positive 3x. And since one of them's positive and one of them's negative, I subtracted 3 from 5 to get 2. The sign of the bigger one was negative, so it's negative 2. Okay? All right. And the last example, before we start trying to draw some conclusions, what if I had x minus 3 times x plus 5? All right, using FOIL, the product of the first, x times x is x squared. The outer product is x times a positive 5, so it's positive 5x. The inner product is negative 3 times x, which is negative 3x. Again, they have different signs. So with different signs, I always subtract, keeping the sign of the greater one. This time it's positive 2x, whereas the last time it was negative 2x. The product of negative 3 times positive 5 gives me negative 15. Our job in section 6.2 is going to be, starting with the trinomial, trying to come back and rediscover what the factors were. So my first hurdle is to figure out what kind of signs things are going to have. And there are some very definite patterns. Let's go back up to the first two. Looking at this, I want you to look over on this side. Okay, look at the trinomials. Look at the first one. Look at the last sign. It's positive. If the last sign is positive, what that tells you, because both of these have the last sign that's positive, what it tells you is that the middle term's sign tells you what these two will be. The middle term sign tells you what these two will be. To get a positive 15, I either have to have a plus times a plus, or I have to have a minus times a minus. That's the only way to get positive 15. Which case is it? Is determined by the middle sign. If the middle sign is plus, they were both pluses. If the middle sign is minus, they're both minuses. Conclusion: if the last sign is positive, the middle term tells you what the two signs will be. Okay? Now, let me go back, and I want to show you something under sign patterns. You can print this if you want. Sign patterns for factoring trinomials. I don't have terms in there, I just have boxes. If the last sign, if the last sign is positive, then both signs in the factors must match the middle sign. Okay? That's what you need to remember. If the last sign of a trinomial is positive, both signs match the middle term. Would you like me to write that down? If the last sign is positive, comma, both factors match the middle sign.
When you get ready to go print this right here,
Uh-huh.
will that be on this
It will
page?
not unless, no, it will not. I will include this though, and it is being included as part of the video. So if you needed to see it again, you could look at the video. All right, let's go back to those examples we were looking at. What happens if the last sign is negative? Then there is always one of each, one positive and one negative, one positive and one negative. It doesn't matter whether the middle term was positive or negative, there will be one of each. Now, the sign of this will help you decide what number to put in the right place, but that's a discussion coming up in a few minutes. So for right now, if the last sign is negative, then you are guaranteed that you will have in the factors one plus and one minus, always. So if I went back, if the last sign is negative, this is back to the sign patterns, then you always get a plus and a minus, a plus and a minus. It didn't matter what the middle term was. You get a plus and a minus. So if the last sign is negative, you get 1 plus and 1 minus in the factors. Always. Okay, so if this last sign is negative, I guarantee you you're going to have one factor with a plus, one factor with a minus. If it's negative, you get one factor with a plus, one with a minus, and it is irrelevant what the middle sign is in making that determination. All right. So now that we have taken a look at that, let's look at the problems, the MyMathLab problems in 6.2. The instructions are going to tell me to factor, and I'm going to be factoring trinomials. So if you printed these notes, then you've got room to work right there on your paper. And the first question you see should be x squared plus 12x plus 32. I need to factor this. Here's my questions that I ask myself. Number one, I think about the flow chart. Is there, to all three of these terms, a greatest common factor? And I think it's no. There's not a number that goes into 1, 12, and 32. Okay? And they don't all have x's. The next thing I do is say, well, how many terms do I have? Because if I have 4, I'll do grouping that I learned yesterday. But I have 3. 3 tells you to try this new technique that we're just embracing called trial and error. So the first thing I do is put down my parentheses. The next thing I do is think about signs, because we hopefully know the patterns. What does the pattern do? The pattern says, well, look at that last sign. That's got to be your first consideration. If the last sign is positive, what did I say? They both match the middle term. And what is the middle term?
Positive.
Positive. So I will have a plus and a plus. Okay? So the rule says, if the last sign is positive, the middle term determines both of those signs. Okay, now we have to think about FOIL, first, outer, inner, last. First is pretty easy. This first position times this first position has to give me x squared. So it has to be x times x. That part's easy. The next thing I have to do is think the last position times the last position has to give me 32. But there's more than one way for that to happen. So I'm going to write down the ways it can happen, and I'm going to write it over here. I'm going to switch over to blue. Do you agree that 1 times 32 would give me 32? And 2 goes into it 16 times, so 2 times 16 would work. 3 doesn't go into it, but 4 does. 4 times 8. And I believe those are all my possibilities. Those are all the ways that I could get 32. Only one of them is right. Now, how do I know which one? It is going to be the outers plus the inners that's going to tell me. Now, if I put in, and I'm going to erase, so maybe you don't want to write this down. Maybe you don't want to write down what I'm about to do. If I put in 1 and 32, what would my outer product be? 32x. What would my inner product be? 1x. Does 32x plus 1x add up to be 12? No. So that was not the right choice. Do you agree that since you're just multiplying whatever you put in those spots by 1, that it doesn't matter whether you put them in here or you just look at them out here? Is 1 plus 32 equal to 12? No, then that can't be the right choice. Is 2 plus 16 equal to 12? Then it can't be the right choice. Is 4 plus 8 going to equal 12? Then that's your choice. Put in the 4, put in the 8, and check it one last time. X times x gives me x squared. And I'm sorry, I accidentally erased my parentheses there. The outer product is 8x. The inner product is 4x. Do those add together to give me the middle term of 12x? Yes. And 4 times 8 is 32. I've got the factors. So in section 6.2, oh, and it's blue again, what you can count on is that it's going to be a plain old x squared. So it's going to be easy to determine what goes in the first spots, x and x. Then you're going to have to worry about how am I going to get a 32? And I have many opportunities to get 32, but they have to combine through addition to give me the middle term. Okay, so there's two criteria. Multiply together to give me the last term, add together to give me the middle term. Let's look at number 2. Let's factor x squared minus 6x plus 5. Whoops. All right, is there a common factor? No. It has 3 terms, which means I'm going to look at trial and error. So I start by putting down my parentheses. Once I've made a determination that I'm going to use trial and error, then I think about the sign patterns. The last sign is positive. So what does that tell us about the 2 signs? No? Both be negative. Okay, the rules are if the last sign is positive, both signs in here match the middle term. If the last sign is negative, that's when you get one of each. Okay, so they're both negative. I know that to get x squared, I need x times x. So that's taken care of. 5. Well, 5 is a prime number. There's only one way to get 5, and it's 1 times 5. Does 1 plus 5 equal 6? Then those are right. And I'm going to check it. X times x is x squared. The outer product is negative 5x. The inner product is negative 1x. Those add up to be negative 6x. And the product of the last, negative 1 times negative 5, is positive 5. I need to check it because you could be making one thing work but not paying attention to the fact that something else didn't work. So 2 criteria. You have to have the last multiply together to give you the last, but they have to add together to give you the middle. Let's look at number 3. I have x squared plus 14x plus 49. My instructions are going to say to factor this. Is there a common factor? No. It's a trinomial, so I'm going to go with trial and error. Okay, signs. When the last sign is positive, they both match the middle term. And I already heard people saying positive and positive. To get an x squared, I know it is x times x. To get a 49, I don't know. There's more than one way. It could be 1 times 49. Do those add up to be 14? Then I don't think that'll work. Another way to get 49 is what? 7 times 7? Do those add up to be 14? Yeah. Then that's what I'm going to choose. I'm not going to feel fully confident until I do FOIL with my potential answer. The product of the first is x squared. The outer product is 7x. The inner product is 7x. Those add up to be 14x. The product of the last is 49. You do not, say you're taking a test for me, you don't have to show me that you're checking this, but I think you should at least mentally check it. All right, number 4. We have x squared minus 5x minus 36. All right, is there a common factor? And by the way, before this lesson ends, the answer to something will be yes. Okay, but it's a no over and over as we start. It's a trinomial, so I'm thinking about trial and error. This time the last sign is negative. What does that tell you?
Negative.
One of each. When the last sign is negative, it is always one of each. When the last sign is positive, it is two that match the middle term. All right, I know it's going to be x and x. Now, I'd like you to take a little look up here. My outer and my inner products. Does everybody see that the outer product will be a negative quantity? Because it's an x times a negative number. The inner product will be x times a positive number. When I add a positive and a negative, what do I end up doing? You end up subtracting.
Yeah.
So when the two signs are different, you're going to be looking for a difference that is 5. Not a sum, but a difference. When the signs are different, looking for a difference. Okay, so here I go with all the possibilities to get 36. It could be 1 times 36. Do those have, and I'm going to even write it on here, a difference of 5? No. Okay, so I tried 2. 2 goes into 36 18 times. Do those have a difference of 5? No. All right, 3 goes in there 12 times. Do 3 and 12 have a difference of 5? No. 4 goes in there. It's 4 times 9. Do 4 and 9 have a difference of 5? Yes. Voila. I've got the right combination. Now, when the signs are different, it does matter where you put them. Okay? You want the difference of these to be 5, and you want the bigger one to be negative because you got negative 5. So what will I put in the negative spot? 9. And 4 over here. And by the way, if you put them in the wrong places, you're going to discover that when you check it, and then you're just going to change them. All right, so the product of the first is x squared. The outer product is negative 9x. The inner product is 4x. Those have a difference of 5. The sign of the big one was negative. That's good. Positive 4 times negative 9 is negative 36. Check it with FOIL. Number 5. I would like you to do this one. Would you factor x squared plus 4x minus 45? And I will stay silent for just a minute. Okay, let's take a look at this together. Is there a common factor? No. It is a trinomial, so I begin with trial and error. The last sign is negative. What does that tell you? One of each. To get an x squared, I know it's going to be x and x. 45 has different sets of factors. 1 times 45. Now let me pause for just a minute. The outer and inner products, will I add them together or will I really take a difference? It will be a difference. And how did you know that? The signs. One's positive and one's negative. So I'm going to be subtracting. 1 and 45 do not have a difference of 4. Okay? 2 doesn't go into that, but 3 does. 3 goes in there 15 times. Do 3 and 15 have a difference of 4? No. All right, 4 doesn't go in there. 5 does. 5 times 9. Do 5 and 9 have a difference of 4? Yes. So that's my choice. When I look at this, I see that not only do I get a 4, but I get a positive 4, which meant the big number had to be positive. So the 9 will go here, and the 5 will go here. And I'm not calling it done till I check it. Product of the first is x squared. Outer product, negative 5x. Inner product, positive 9x. Do those have a difference of positive 4? Yes. And a positive 9 times a negative 5 does give me negative 45. So make sure you're checking things. Let's look at number 6. How'd y'all do on that one? Did you do okay? All right. Number 6, x squared plus 5xy plus 4y squared. Is there a common factor? No. But please notice something characteristic about this trinomial. All the others that we've done have been an x squared, something times x, and then a constant. This one, just a little bit different. It has an x squared. It has what's sometimes called a mixed term. It has xy, and then it has y squared. That's not going to be a problem to us. There's no common factor, 3 terms, go into trial and error. Let's focus on signs. That's what I like to do first. This is a plus sign, which says what? They're both the same as the middle term, both plus. So when I say, what are the signs? You look straight at the last one. If it's positive, they are both this sign. If it's negative, it's always one of each. Okay, so I got pluses. Now, I know that it's x times x to give me x squared. To get 4y squared, I'll worry about the numbers in just a minute, but do you agree that there must be some y's in there? That's what's a little different about this particular example, is I've got to keep the y's. Easy to forget. Math Lab will simply tell you you're wrong. I might be slightly forgiving on a test. I might count off 1 point. But do your best to try to remember it. All right, now my outer and my inner, because they're both positive, I'm going to be looking for a sum of 5. So for 4, it could be 1 times 4 or 2 times 2. Which of those will give me a sum of 5? 1 and 4. And it doesn't matter at all where I put them because it's all pluses. Check it. X times x is x squared. Outer product is 4xy. Inner product is 1xy, even though the 1 is not usually written. Add them up for 5xy. Product of the last, 4y squared. If you were typing this in to my math lab, most probably you would just type in x plus y times x plus 4y. You would not type in the 1, that 1 right there. Is that okay? So don't be surprised if you have squared term on the front and a squared term on the back, and the mixed term in the middle. Let's look at number 7. Yes. All right, let's factor a squared minus 10ab plus 16b squared. This time I have 2 variables. I have an a squared on the front, a b squared on the back, and an ab in the middle. There is no common factor to all those terms. I will try trial and error. The signs. Go to the last sign. It is positive, which tells you they're going to both match the middle term, both minus. I know that I'm going to have an a times an a to get a squared. I know that whatever the numbers are in the last spots, they're going to have b's with them. And now I'm going to work with the number 16. Because the outers and inners have the same sign, I'm going to look at a sum. I need the sum to be 10 for 16. Is it 1 times 16? Do those add up to be 10? Is it 2 times 8? Yes. There's no reason for me to look at other possibilities. There is another possibility. There is 4 times 4, but I don't really care about that because I already found the right one. So throw the 2 and the 8 into spots. Because the signs were the same, I didn't care which one went where. And I get a times a is a squared. Outer product is negative 8ab. Inner product negative 2ab. Those combine to be negative 10ab. The product of the last, negative times negative gives me positive 16b squared. Okay, are you remembering the sign patterns? It will help you. Number 8. Well, come on. Oh my goodness. All right, let's factor 2x squared plus 28x plus 96. Now, what's that first question I keep asking over and over? Is there a greatest common factor? And finally, the answer is yes. If I look at 2x squared plus 28x plus 96, there is a common factor of what? 2. So I have to factor that out first. Now, if you want to, if it's helpful to you, show where you are dividing that 2 out. If that helps you. That gives you x squared plus 14x plus 48. Now, yesterday, when you were working on section 6.1, if you found a common factor and factored it out, you were finished with the problem because you didn't, at least as far as our book is concerned, you didn't know to try anything else. Now you have more knowledge. Not only did it have a common factor of 2, but this polynomial is a trinomial that looks a whole lot like what we've been factoring. So I'm going to hang on to the 2 because it is a factor. And I'm going to set up my 2 parentheses because I might be able to factor the trinomial factor further. Trial and error. This is the first 2-step problem we've looked at. Signs. Okay, the last one's positive. Both match that. Plus and plus. I need an x and an x. Because the outer is positive and the inner is positive, I know that I'm looking for a sum of 28. Okay? All right, so I'd start with 48. Is 1 and 48, the sum has to equal 28. Will that work? No, 1 plus 48 will not give you 28. So let's see. 2. It's 2 times 24. Is 2 plus 24 going to be 4? I'm so sorry. Okay. Y'all are looking at me weird, and I finally caught on to what the weird look was. I needed to forget about this original one and only focus on, so this mistake will be recorded on video. Yes, to my embarrassment. I need to be focusing here, so I need a little help. I'll have to highlight things so that I'll see them correctly. My sum is not 28. My sum has to be 14. Now, the answers to my questions remain the same. 1 and 48 don't work. 2 and 24 don't work. But I was wrong before. All right, does 3 go into 48? Yes. It's 3 times 16. We probably don't carry that pair around in our head, but does 3 plus 16 equal 14? No. 4 goes in there. 4 goes in there how many times? 12. Is 4 plus 12 14? No? Okay. How about 6? 6 goes in there 8 times. Is 6 plus 8 14? Yes. So 48 had a lot of choices, and it was the last one that worked. 6 and 8. Now, to check this problem fully, it would take 2 steps to check it. First of all, I would check with FOIL. X times x is x squared. The outer product is 8x. The inner product is 6x. Those add up to be 14x. And the product of the last is 48. To fully check it, then I would distribute 2 and get 2x squared. 2 times 14x, 28x. 2 times 48, 96. It took 2 steps to factor it. It would take 2 steps to check it, if you were so inclined to check it. Your final answer to get credit must include the 2, the x plus 6, and the x plus 8. And there is not a rule about what order those need to be written. So you could have 2 times x plus 8 times x plus 6. Commutative property of multiplication says they're both right. All right. I would like you to try number 9. It is 4x squared plus 16x plus 12, and I'd like you to factor that completely. Okay. Some of you are through and some of you might not be, but if we join together, is there a common factor?
Yeah.
Okay, what is it?
4.
4. Now, somebody might have said, well, I thought the common factor was 2. 2 is a common factor, but why is that not correct?
Because
It's not the greatest common factor. So I want the biggest one, and that would be 4. So if I factor 4 out of that, it's going to give me x squared plus 4x plus 3. And looking at that trinomial factor, it looks like the problems I've been working on. It has an x squared and an x term and a constant, and I'm going to give it a shot. Don't lose the 4. Signs. The last sign is positive, which means take the sign of the middle and write it down twice. To get x squared, I know I need x and x. Am I going to be looking for a sum or difference to equal 4?
Sum.
A sum, because they were the same. So the sum has to equal 4. So I'm going to have, for the number 3, well, I'm a happy camper, because 3 is a prime number. So I only have 1 and 3. Is there some 4? Yes. And so I'm done. And certainly you could check it. I'm going to perhaps not check these as frequently in class, but I do recommend that you check them. Okay? Let's look at 10. Let's factor 4x to the third minus 20x squared plus 24x. Do you see a common factor? Yes. Okay, what will go into all these numbers? 4. Is there a common variable? Yes, x, because remember I take the low power. If I divide each of these by 4x, that's going to give me x squared minus 5x plus 6. Does this trinomial look like something I should be able to maybe work on by trial and error? Yes. Don't lose the 4x. And something that I probably need to keep doing is highlighting that so that I focus on it and I don't just get crazy and start going to the wrong thing. Tell me about the signs. The last sign is positive. Both negative. Both negative. So I know that I need an x and an x. I'm going to have to, you tell me, will I be looking for a sum or a difference to equal 5?
A difference.
Both are going to be negative. The outer product will be negative something. The inner product will be negative something. When you add two negatives, you add them. Okay? So it is a sum. The sum has to equal 5. All right, to get a 6, 1 times 6. Is 1 plus 6 going to equal 5? No. 2 times 3. Is 2 plus 3 going to equal 5? Yes, then that's my choice. Now, see, you have to be so careful on this one because 6 is a weird number when it relates to 5. The sum of its factors equal 5, but the difference of the other factors equals 5. So you have to be careful. What tells you it's a sum? Signs were alike. If the signs are alike, you add the numbers and keep the sign. Is that okay? All right, let's Let's skip a few problems. Let's go to 14. I have x to the fourth minus 12x to the third minus 28x squared. And I'm supposed to factor that. What is the first question? Is there a common factor? Yes, x is in all of those. What power of x can I take out? X to the second. You take the low power out. So x to the second is my common factor. If I divide x to the second out of each one of these, I'm essentially using the quotient rule, which says to subtract the exponents. So I have x to the second minus 12x minus 28. The trinomial that I'm looking at here appears to have the characteristics of trinomials that I know how to factor by trial and error. So I will keep the x squared. And would you tell me, based on the last sign, what the two signs in the factor should be? One positive, one negative. When the last sign is negative, it's always one of each. I know it's x and x. Because one of the products, the outer will be negative and the inner will be positive, will it be the sum of those quantities or the difference of those quantities that equals the 12? Difference. That's kind of, ooh, that is a mess. I hope that you can remember, if they are different, it's difference. If I could write neatly enough. Okay, so I am focused on this trinomial right now. 28. Is it 1 times 28? Do those have a difference of 12? No. All right, 2 times 14. Do those have a difference of 12? Yes. I don't care about anything else. I know 4 times 7 would work, but I don't care because I found it. Now, if all you want to do is randomly throw them in there and check it, you could do that. If the sign turns out to be wrong, you change it. You change the signs. But let's be a little wiser than that. Their difference is 12. But it's a negative 12, which means the dominant or the big number had to be negative. So we should get it right if we put 14 there and 2 there. And then we double check. X times x is x squared. The outer product is negative 14x. The inner product is positive 2x, which does give me a negative 12x. And the product of the last is negative 28. Is that okay? Now, a characteristic that every trinomial in this section had was when it came time to do trial and error, the coefficient of the squared term was a 1. Maybe it didn't start out as a 1, like number 10 did not start out as a 1, but by the time you got the greatest common factor out, the leading coefficient was a 1. What that did was make it so much easier to figure out what to choose. Section 6.3, that will not be the case. Okay? If you happen to have taken Math 307 with me, we didn't do section 6.3. Okay? All we do in there is 6.1, 6.2, and 6.5. So this next section most probably will be new to you. So I'm going to go to section 6.3, but I'm going to stop for just a minute.